Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Today I will discuss about a very important topic which is related to mole, which is molar volume. The word volume, the word volume is usually used for gases and liquids, gaseous substance or liquid substance. Okay, and we know for solid we use the mass unit such as gram unit, gram, kilogram, milligram. Okay, and for gas or liquid we usually use the volume unit, which is mainly liter, ml, milliliter. Okay, when we buy any soft drinks, we mention 1 liter, 2 liter, 3 liter, etc., or 500 ml, 250 ml. Okay, and for gas also we mention 1 liter hydrogen gas, or 2 liter oxygen gas, 4 liter carbon dioxide gas. And that means volume is used for gas or liquid. And the term molar volume is used only for gases. Okay, it's a very important point. You have to remember that the molar volume is only applicable for gases. Okay, so that's why now we have to know about what is molar volume. Before defining the molar volume, I will mention a term which is STP. Okay, I think it is a new term for you, STP. In chemistry, 0 degrees Celsius temperature and 1 atm pressure, that means 1 atmospheric pressure, is known as STP. 0 degrees Celsius temperature and 1 atm pressure is called STP. That means, and STP means standard temperature and pressure. STP means standard temperature and pressure. It's a standard condition for any chemical substance or any chemical reactions. Okay, and now I will define the molar volume. The volume of a mole of any gas, the volume of 1 mole of any gas at STP, okay, is called the molar volume of that gas. Okay, that means the volume of 1 mole of any gas at STP is known as molar volume. Okay, and this temperature, this condition, STP, is very important for that, because we know the volume is dependent on pressure and temperature. If we increase the pressure and temperature, if we change the temperature and pressure, the volume will be changed. If we increase the temperature, the volume will increase, and if we decrease the temperature, the volume also decrease. And if we, that means the relation is directly proportional to proportional relation. Okay, and if we increase the pressure, then volume decrease, and if we decrease the pressure, then volume increase. Okay, that's why it's very important to maintain the fixed temperature. So if we keep the temperature and pressure fixed, then and this fixed temperature will be 0 degree Celsius temperature and 1 atm pressure. Then if we measure the volume of 1 mole of any gas, the volume will be considered as molar volume. And for all gases at standard condition, that means at STP, the molar volume is 22.4 liter. That means the constant value for all gas, for oxygen gas, hydrogen gas, carbon dioxide gas, ammonia gas, for all gas, if we take 1 mole of any gas and keep the temperature fixed at STP, the molar volume is always 22.4 liter. Okay, 22.4 liter. Okay, if I explain this by drawing something, it will be more clear to you. Okay, then I draw 3 balloon. Okay, I draw 3 balloon. Okay, then I insert hydrogen gas in this balloon and 1 mole of hydrogen gas. Okay, I take 1 mole hydrogen gas in this first balloon and then 1 mole of oxygen gas in this balloon and 1 mole of carbon dioxide gas, 1 mole of carbon dioxide gas in this balloon. Okay, and we know, we have already know 1 mole of hydrogen gas means 2 gram hydrogen gas. Okay, in our last class I have discussed about that. Okay, 1 mole of hydrogen gas means 2 gram hydrogen gas, and similarly we know 1 mole hydrogen gas, oxygen gas is equal to 32 gram oxygen gas, and carbon dioxide, 1 mole carbon dioxide is equal to 44 gram carbon dioxide gas. Okay, and then after filling these 3 balloons, if we calculate the volume of these 3 balloons, then what we get? Okay, we find that after filling the balloons with 3 different gases, we find that the volume of 3 balloons are same. The volumes of 3 gases are 3 balloons are same, and which is 22.4 liter, and this is 24 liter. This is 22.4 liter. Okay, and this is known as the molar volume of that gases. Okay, and for 3 different gases, the molar volume, and for that of course we have to fix the temperature and pressure. This done at STP. Okay, now that means the volume, whatever be the gases, whatever be the mass of these gases, if we take 1 mole, then the molar volume always at STP 22.4 liter. Questions may be arise in your mind. Hydrogen is a small tiny particle, tiny gas, and carbon dioxide is bigger than that. Okay, how it is possible? Okay, why it is possible? Okay, why? The reason behind that is the intermolecular space. Okay, in this volume, carbon dioxide particles, carbon dioxide molecules are closer to each other, but for lighter particle hydrogen, the hydrogen molecules are spaced apart from each other, but the number of molecules in it are same. How and which is that? Now we have to know. You have already know. You can guess that. And how many molecules are present in that volume? These volumes. Of course, this is Avogadro numbers. Of course, we know the relation of mole and Avogadro number with the Avogadro number. And now we have to clear that the relation of molar volume with the Avogadro number. And we know in 1 mole of any substance, Avogadro number, that means 6.023 into 10 to the power 23 molecules are present. And if 1 mole any gas take 22.4 liter volume, then in 22.4 liter volume also Avogadro number, that means 6.023 into 10 to the power 23 molecules are present. For this also, for that also 6.023 into 10 to the power 23 molecules present, and for this also same. Okay, is it clear? Very simple relation. Okay, 1 mole of any gas, that means take example 1 mole of any gas contains molar volume of gas, and which is 2 gram molecular mass in gram unit, and this mass take the volume, the molar volume, which is 22.4 liter, and in 22.4 liter, that means in molar volume at STP 6.023 into 10 to the power 23 molecules of gases are present. And by using these values, 3 mathematical formula are given in your book. Okay, and by using this mathematical formula, you have to do some problems, especially for MCQ. These formulas will be very helpful for you. Okay, and you can also apply the unitary method, but in your book these 3 formula since are present, you can easily use that. And this 3 formula is very simple. M is equal to, at first, W by M, capital M, and another one, second one is V, capital B by 22.4, and third one is capital N by 6.023 into 10 to the power 23. Okay, very simple. You have to remember that. Try to remember that. Okay, and N is equal to here. N is equal to number of moles. And W is equal to given mass. Given mass. M is equal to molecular mass. And V is equal to volume in liter. This is very important. You have to remember that. This is volume in liter. Okay, this is also liter, this is liter. and capital N. Capital N is number of molecules. Number of molecules. Okay, students, I think formulas are clear to you. Okay, N, W given mass, and M molecular mass, V volume in liter unit, and N is equal to number of molecules. Then I will solve a problem, a very simple problem from your textbook. Okay, from your textbook. I want to erase this. Okay, this side. The problem is calculate the number of moles. Okay, number of moles are present in present in 5 gram water. 5 gram water. Calculate the number of moles which are present in 5 gram water. Okay. Now, look at the problem. You have to find out the number of moles. We have to find out the number of moles. Okay. Number of moles. That means N. Number of moles. That means N. And here 5 gram is given. That means mass is given. Okay. That means W is given. And molecular formula of water is given. And from molecular formula, we can easily calculate the molecular mass. Okay. From molecular formula H2O, we can easily calculate the molecular mass of water. And then, choosing this formula, choosing this first formula, we can solve this problem very easily. Okay. N is equal to, you have to find N. W is 5 gram, given mass 5. And molecular mass is, you have to calculate the molecular mass. Water, we know water, molecular mass of water is 2 plus 16, 18. And you have to write this 18 here. Okay. And you get the value, put in these two values. You have to calculate and put the answer here. Okay. Very easy calculation. And within a few seconds you can calculate this. And these formulas are very helpful for solving the MCQ problems. Because time is very important for this part of this, the MCQ part. Okay. And similarly, you can apply this formula also, and you have to practice some problems from in your book and from our supplied worksheet. Okay. And then I will discuss about another problem which is also in your book. In your book, which is also in your book. How many molecules? How many molecules are present in 1 liter carbon dioxide? 1 liter. 1 liter carbon dioxide at STP. At STP. Problems related to molar volume related problem, their condition must be mentioned. Okay. Then you have to solve this problem. How many? You have to find out how many molecules are present, and to solve this problem, you have to start the problem with the molecular mass. The molecular mass of carbon dioxide. Carbon is 12. The atomic mass of carbon is 12. Oxygen 16 into multiplied by 2 is equal to 44. This is the 44 is the molecular mass of carbon dioxide molecule. And now you have to express this in gram unit, and then this 44 gram carbon dioxide can be considered as 1 mole of carbon dioxide. We are already known about these relations, okay? 44 gram carbon dioxide is considered as 1 mole of carbon dioxide gas, okay? And we know 1 mole of carbon dioxide gas take the volume at STP 22.4 liter. 22.4 liter, which is the molar volume of carbon dioxide. At STP. And we also know about that in molar volume in 22.4 liter any gas, and in that case carbon dioxide, Avogadro numbers of molecules are present. Okay, all relations are here. Okay, then now look at the problem. Okay, how many molecules? You have to find out how many carbon dioxide molecules are present. 1 liter carbon dioxide. That means we need this volume, these two relation, these two quantity. Okay, and we have to start with the volume. 22.4 liter carbon dioxide contain 6.023 into 10 to the power 23 molecules, and then 1 liter carbon dioxide. 1 liter carbon dioxide contains how many? You have to divide this number with 22.4 liter. Okay, and if we calculate this using your calculator, you get the answer. Okay, you get the answer. Very simple mathematics compared to other mathematics. Okay, your general math, higher math, physics, okay, chemistry, mathematics are very easy. Okay, then just you have to remember the informations and correlate them. You have to correlate them and sometimes apply formula, and then you can easily solve these problems. This is no more today. This is all for today, and you have to practice the problems, the math problems from your book and from the supplied worksheet also. Okay, be happy, be safe. Assalamu alaikum, students.